Assalamualaikum and a perfect day to my respected panel. My name is Nurnajihah binti Abd Kadir with student ID B0919100143. I will present my Project Sarjana Muda with the title The Design Analysis of 3D Rotor Frame Sub-Assembly 1. Dr. Hambali bin Bojang guide this project. From the problem statement, two objectives must be achieved in this project. First, I would like to introduce Computer Numerical Control (CNC) three-dimensional rotor machine. CNC is a computer-controlled cutting machine that typically mount a hand-held rotor as a spindle used to cut various materials such as wood, composite, metals, plastics, glass, and foam, which talent development program will build. There are two types of example of CNC machine. Roland MDX540 3D machine and CNC milling with laser engraving and cutting. Talent development program Developing Tomorrow is Engineering Expertise is a program created where a group of students is placed under one organization to build a V2 3D rotor machine project. This organization group is similar to professional groups such as Investor because it is led by a project manager and has other departments. This TDP program aims to expose students to the real world of the industry before students enter the world of work after graduation. Most 3D rotor used nowadays is Computer Numerical Control (CNC rotor). CNC 3D rotors are controlled using a computer by uploading program into the machine controller. So from that, the team plans to create a 3D rotor machine that can engrave wood, plastic, and nylon with low-cost development integration. This project will be conducted based on a design analysis of a 3D rotor sub-assembly. The need to use computer-aided engineering (CAE) to simulate the performance of the frame structure but at the 3D rotor to improve the design and resolve the issue. The problem statement for this project are TDP program is conducted to provide opportunity to students who need skill and experience included in the government objective of improving the student learning experience. The price for a CNC 3D rotor in the market is high, but the existence of this program can help small trader to own a CNC 3D machine to run a business. In addition, this machine is intended for education, so polytechnic, vocational school, skill school, and secondary school majoring in design and technology can buy this machine. This machine was created to reduce development costs and customer can buy at a lower price than the market price. The objective of this project is to design and develop a frame structure of a 3D rotor machine. Second objective is to analyze the frame structure using computer-aided engineering and the first-order calculation of the 3D rotor. For the literature review section, most refer to journal and books for this project to carry out this research. The first book referred to a product design and the sixth development edition 2016 was published by McGraw-Hill Education, Carl T. Arish, and Stephen D. Epiker. The new product development flow is as follows: product planning, concept development, system level design, detail design, testing, and mass production. For the following literature review, I have referred to a book by Rudolph J. Eckert, 2005, Engineering Design. Pierre Prentice Hall, USA, published them. During the design phase, the flow starts from formulate, concept, configuration, parametric, and detail. We will go through one by one for these phases. Establishing target specification is to define what the product is supposed to do, set it early, and refine it as the team zeroes in on a choice of a product concept. There is the process of determining target specification. First, prepare the list of metrics, collect competitive benchmarking information, set ideal and marginally acceptable target value, and last, reflect on the result and the process. There are three methods of concept. First is concept generation. The procedure involved in this method are clarify the problem, external information, in-house information, systematic combination and review of the result. The second method is concept selection. Concept selection is analyzing concept in terms of client demand and other criteria, assessing their relative strength and weaknesses, and selecting one or more ideas for further investigation. The last method is a final specification. The following is a 5-step procedure for developing final product specification shown in figure. Modularity is a relative attribute of product architecture. According to Arish, and usually a product is strictly modular or integrated. Next is DFMA. DFMA is an engineering methodology that focuses on reducing time to market and total production cost by prioritizing the ease of manufacture for the product part and the simplified assembly of those parts into the final product. The table shows the example of a DFA summary before the FMA analysis. For parametric, computer-aided engineering (CAE) will be used to perform the analysis. It will be explained in more detail in the methodology. Computer-aided design is the process of creating a design or drawing using a computer. Designers commonly use drawing to show and describe the product design they are working on. Computer-aided engineering is standard in almost any industry using design software to develop product. CAE is the next step in designing a product and supporting the engineering process, as it allows to perform tests and simulation of the product physical properties without needing a physical prototype. Simulation analysis types include finite element analysis, computational fluid dynamic, thermal analysis, multibody dynamic, and optimization. This is the flowchart, and according to the flowchart, final year project 1 starts with an introduction, literature review, and engineering design. So objective 1 will be achieved in last year's project 1. The structure frame was created using SolidWorks software shown in figures. The information gathered was based on a concept agreed upon by all members of the talent development program team. From the flowchart, it can be seen that engineering design was in the final year of Project 1. This means Project 1 for this project has been achieved, which is to design and develop a frame structure of a 3D rotor machine. The target specification included the collection of competitive benchmarking data. The competitive benchmarking analysis table utilized to obtain the data is shown in the figure above. This method evaluates a competitor's product and compare it to one's own based on criteria. A product concept is a broad description of the product technology, principle of operation, and appearance. It is a synopsis of how the product will meet the customer needs. The systematic combination technique was utilized to tackle the challenge and produce the CNC 3D automation concept. The figure above shows the combination table of idea and the total number of combinations. Concept selection is determined by examining concept in terms of consumer needs and other criteria, comparing their relative strengths and weaknesses, and choosing one or more idea for further investigation, testing, or development. The concept selection for the 3D rotor machine was decided using the weight rating approach. The specs are checked when the team decides on an idea and prepares for subsequent design and development. Previously, specifications were target given as broad range of value, but they have been polished and developed. This uses the final specification table to list the last parameter for the 3D rotor machine. This project will calculate a load of static analysis by using point load and uniformly distribute load formula. As shown in the figure above, there are many types of load: point load, point moment, uniformly distribute load, and triangular distribute load. The calculation is required in this study. It is a way to find an accurate value. When the computer-aided design model is available, the design can be uploaded into 3D software to run the simulation. After that, the result will be compared with the first-order calculation. This calculation will conduct in the final year of Project 2. This session explains the finite element analysis data undertaken after analyzing the frame structure. The example of the analytical and FEA analysis result table will be used in this analysis. All the data will be included in the analysis table to make it easier to compare the result between the first order calculation and the FEA result of the structural frame. Finite element analysis uses calculation, model, and simulation to predict and understand how an object might behave under various physical conditions. Engineers use FEA to find weakness in their design prototype. This is the Gantt chart that was used for this project.